Okay, today we're going to do some more stuff similar to what we did yesterday. Now, some of the questions might come across a little bit differently. Some of these questions are designed to be similar to EQAO questions, so we're going to talk about some strategies for that and some different ways that you can approach these questions. I've talked a lot about different strategies that you can use, and we're going to talk about some different strategies you can use today as well. Okay, and we're going to continue to look at different examples of applications and just more practice of similar kinds of stuff that we've already done and talked about. So let's get started. First question, to attend the Cambridge Fall Fair, there is an admission fee and a cost to go on each ride. Stop there and think about that. So this is explaining in words, which is something we are going to have to do eventually, but this one's not really giving us the information in words. It's just talking about the situation. But let's think about what this means. So when you walk in the door, you pay an admission fee. You haven't even gone on a ride yet, and you've already paid money. Then every time you go on a ride, each ride, there is a cost. That's a cost per ride, right? Each ride per ride. So there's a one-time cost that you pay at the very beginning, and then there's a cost for each ride. And what does that already start to sound like? I hope it sounds like a linear relation, because a linear relation is all about where does it start and what is the change. And per means change, and the admission fee is how much you pay for 0 rides. Just at the very beginning, before you've done anything, you have to pay that amount. So that's your starting amount. Okay, and I'm going to make a note of that. The admission fee is your start, and the cost per ride is your change. Okay, so we're going to use the graph to figure that out. What's different about this one from the one we did yesterday, although we talked about this and the practice had some of this, is there's no points on this graph. So I can go ahead if I like points and I can pick points. And I've said this before, I'm not going to pick that point because it's not a nice point. It's not where the grid lines meet, but this one is. I've got a grid line going this way and this way, okay? And this one, and this one, and this one. So I've got a lot of points here. I only really need 2 points, but I've got a whole bunch if I want. So what's the admission fee? What's the cost for 0 rides? The cost for 0, the number for 0, or the number to start, and it's just where the line starts. It's how much for 0, and in this case it looks like $10. What's the cost per ride? Well, very similar to yesterday. I'm going to find 2 nice points, and I'm going to see that this is actually for 2 rides. And in 2 rides, the cost changes from $10 to this marker, which is how much? Again, we have to look at our scale and decide what it's counting by. 5, 10, 15, 20. Okay, that was counting by 5s, so every line is worth 5. So if this is 10, 5 more from that is 15. So for 2 rides, I've gone an increase of $5, right? Or an increase of 5. We don't have to worry about the units right now. From 10 to 15 is a change of 5. If I want, I can do 15 minus 10 and get that answer, which is 5. But if I can just think about that in my head, what was the change there? What did it increase by? I might be able to just do it in my head. But that's $5 for 2 rides. We want the cost per 1 ride. So I'm going to do 5 divided by 2 on my calculator. And if it gives me a fraction like this, because my calculator is in that mode, I'm going to click the button to turn it into a decimal because I don't want fractions for this. 2.5. So that's 2.5. And that is dollars per ride. In this case, it didn't ask for the units, but I think it's a good habit to form because you always want to be thinking about units, and sometimes you're going to be asked about the units, and so why not practice more often? Okay, but it didn't ask for it, so you don't have to. So $5 for 2 rides is, whoops, I sort of wrote that strangely, it's $250 per ride. We'll write it with 2 decimal places because it's money, so we'll write it out properly. Okay, so $250 per ride, $2.50 per ride. Now my equation, and remember we have 2 ways of writing this, so I'll flip back and forth on the different ways that we might write these. But for this equation, this is one, I was talking about this yesterday, where if it gives you the variable, try to use that variable, okay? Because it'll just be a bit more clear. So this one calls the total cost C. So I'm going to start with C equals, and it says the number of rides is N, so that's a lot like the one we did yesterday. And in this case, I'll write it this way. I'll start with the change, 2.5 or 250 times N plus 10. And remember, we talked about this yesterday. In fact, whoops, let me go back. There's that thing we did yesterday. Go back and look at that note if you want to again. But this is the change is the one that's beside the N, and this is the start, or how much for 0, the one that's by itself. Because this one's being paid every time there's a ride. So if there's 5 rides, I'm paying it 5 times. If there's 10 rides, I'm paying it 10 times. If there's 2 rides, I'm paying it 2 times, which would be 5, right? But this $10, I'm just paying it once when I walk through the door. I don't pay it every time. And that's why the change is multiplied by the variable. Okay? So again, that's another example of coming up with a rule from a graph. The following graph shows the relationship between the amount, so this is the second question, the amount of money in a bank account A and the time in days T. So total money A, time in days T, gives us the variables again. But why is this question different? Well, take a look. It's giving us 4 options for our answer. And we've talked about this. EQAO does multiple choice, and we'll do a little bit of it in this class as well. And one of the great strategies for multiple choice is if you can eliminate answers. Okay, so let's take a look at all 4 of these and just start talking about it. But it does always come down to what is the change, where does it start, and what is the change. In fact, before we move on, let's take a look at all 4 of these. How do I recognize the change? The change is what gets multiplied by the variable. So the change for all of these is that, 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 and that. Okay? Whereas the start for all of these is this, because that's a number all by itself. Now, every one of these has the same start. So that's not going to help. And if I go up, look at that. It starts at 500. So that makes sense. That doesn't help though, because it doesn't help me eliminate any of my possibilities. So how am I going to eliminate possibilities? Well, what else am I seeing that is the same and what is different? Well, 2 of these have 100 and 2 of them have 10. So it's obviously going to be either 100 or 10. But the other thing is one of the 100s is positive and the other one is negative. And one of the 10s is positive and one of the 10s is negative. So it ends up boiling down to, I have to figure out if it's 100 or 10, and I have to figure out if I'm adding or subtracting. Well, how am I going to do that? Well, we've talked about this. Do you have a hunch on whether we are adding or subtracting? Because this line is going down, which means we're starting at $500 and going down over time. And later on, I have less money, right? At this point, it looks like we're at $250. So I should be subtracting every single time, right? Because this line is going down. That means it's not A and it's not C, because those ones are adding And if I'm adding, my line would be going up. But these are both examples of my line going down because I'm subtracting. Now I have to figure out if it's 100 or 10. Lots of ways you could do this. You could just trial and error. It gives me the equation. I could pick a point. I could pick 10, plug it into the equation, and figure out what I get. If I plug it into this one, I can figure out, will I get 400 because that's what I should get, or I can plug it into this one and figure out if I get 400. That's one way I could do it. The other way I could do it is just like we did before. We could just figure out what the change is on our own, and that's the one that I'm going to do. Okay? But again, there's different strategies that you could use for this. You might just be able to tell that one of them doesn't make any sense and you're confident that it's the other one, right? It's going to be different for everybody. So if I pick these 2 points, that's a change of 10 days because it went from 0 days to 10 days. And that went from 500 to 400. So that actually went down 100. I'm not going to worry too much about the fact that it went down. If all you had was 100 there, you'd be fine in this case, okay? But it went from 500 down to 400. So I actually went down. And that's easy to tell because that point was listed. If that point wasn't listed in the scale, I might have to do some work to figure out what it is. So 100 down 100 in 10 days is 100 divided by 10, which equals 10. And I already determined that it was minus 10 because I already canceled out the plus. So that's why I didn't worry about this minus. If I put the negative in there, it's going to equal negative 10. But I'm not worried about that because I already know it's the negative 1. So now we've determined that D is the correct response for this question. I knew it was subtracting because the line was going down. If I didn't know that, but I realized it was going down 100 and I did it this way and got the negative 10, there's another way that you could figure out that it has to be this one instead of that one. Because C is adding and I can clearly tell that this is negative. But I think, at least for me, the easier way is just to remember, hey, this line's going down. So if I just do 100 divided by 10, I get 10. But I know it's got to be this one because this is the one going down. Okay, so that's another example of these kinds of questions, one with multiple choice. Let's go on. An electrician charges an initial fee plus an additional cost per hour. The relationship is shown in the graph. Write an equation for this relation. So no, there's question number 4. There's no steps like there were for this one where it tells you to find the admission fee and the cost per ride. There's no multiple choice. This one we have to do everything on our own. But again, it's always going to boil down to what is the start? What's the change? I can always just for myself realize that's what it's asking me to do. Then I can write the rule. Okay, so what is the start? There it is. So do I have to figure out what the scale is? I counted 2 squares to get to 100. So 100 divided by 2, or if you're good at figuring that out and you see that it's 50, because I'm counting by 50, 50, 100, 150, 200, 250, 300, right? Whatever you're counting by. So the start is 50. Again, I don't need to, 50. I don't need to put units there, but it's cost. So I just happen to be thinking about it. So I wrote in the $sign because that is the units. Now, hours, I'm going to find the change. So look at this. I'm going over 2 squares, but 2 squares only takes me to 1 hour. Right? That's 1 hour. So in 1 hour, I went from 50 to 100, which is up 50. Again, I could use my calculator to calculate that if I want, but if I can do it in my head, then that works too. So I've gone 50 in 1 hour. So the change is $50 per hour. This is a strange question. It wouldn't be a good test question because you wouldn't be able to tell which 50 is which when I put them in the rule. Both of the start and the change, in this case, both happen to be 50. Okay, I'll use C for cost. So cost equals, and I'll use H for hours. So 50 to start plus $50 per hour. So in this case, this 50 went here. That's the change. And this 50 went there. That was the start. You can't tell which one's which, okay? And notice how in this case, I put the start here and the change here, whereas for question number 1, I think I did it the other way. I had the change here and the start here, and we've talked about this a lot, but I like to repeat it. It doesn't matter which order you do it. What matters is where the variable is, okay? So that's that one. Even though it didn't tell me to, I still determined what the start was and what the change was in order to write the rule. Write an equation, that means rule, right? Hopefully we're starting to get that now too because we've used both of those terms lots. Okay, we got one more example here. Total cost of renting a boat at a beach is made up of a fixed fee. That's going to be your start. A fixed amount, initial amount. Admission was from question number 1. These are all different ways of saying how much upfront. What's the upfront cost? A fixed fee. It's fixed no matter how many hours you're paying that much. The table below shows information about the total cost. Graph the data in the table on the graph, on the grid provided. Okay. Write an equation that relates the total cost of a ride C to the time the boat is rented. So hopefully we remember some of the graphing that we did before, and I can go ahead and graph this quickly. At 2 hours, which is 2 hours, I cost $100, which is $100. And where do those two meet? Right there. At 4 hours, it was 150. So 4 hours is 150. Well, I have to figure out where that is. So this looks like it's counting by 25s. 25, 50, 75, 100. 125, 150, 175, 200. So there's 150. Don't have to write that in. I'm just doing that for our benefit. And then follow this over and follow this up, and they meet there. And for 7 hours, it costs 225. So 6, 7, 8, there's 7 hours. 225 is there, 200 plus another 25, and that's where they meet. And these three should absolutely form a line because this is a linear relationship. That's what we're talking about. What if they didn't form a line? What if I didn't realize that? What if I thought this was going 2, 4, 6, and I didn't read it carefully and I thought that was a 6? Okay, and then I would have put the point here. And when I went to connect them with a ruler, because you have to connect them with a ruler, look at, I can't connect those with a ruler. You don't just do it like that, where it kind of goes through all of them. That red point is wrong because you can't connect these 2 points down here with that red point. Okay, so that tells me, whoops, that tells me that would tell me that the red point is wrong and that I've made some kind of mistake. Okay, so now I've lined up my 3 good points and I am going to connect them. And there you go. Okay, I'll get rid of that red one for now. All right, and there's my line. Now, I want to talk about a few things here. Actually, let's do this first. If we want to write, I've graphed the data, so I'm done with that part of it, right? But now it wants me to write an equation. Well, what do I need for an equation? I need the change, which I haven't really done exactly yet, and I need where it starts. Two different ways you could get the start. This is where our um, uh, strategies come in. I can pick the start from here. I can pick it from the graph, right? And it looks like 50. So the start equals 50. And then the change I could get the way I've been getting from graphs, or I could get the change from here. So from 100 to 150 is plus 50, and from 2 to 4 is plus 2. So my change is 50 divided by 2, which is 25. Okay, so I've got my change of 25 and I've got my start of 50. If I had done that from the graph, I would have noticed that this is from 50 to 100 is plus 50, and that was from 0 to 2 plus 2. So it's the exact same numbers, whether you're doing it from a table or doing it from a graph. Okay? So that means I can write my equation. Let's go ahead and do that and get that done. C equals my start, 50, plus 25, my change, times h. That was the equation, or that was the variable I think that it wanted me to use. Did it have h up there as well? Okay. So I used a bit of information from the table and a bit of information from the graph to come up with that one, and I wrote out the equation. Now, before we finish, I want to go back and talk about a couple of things. Something that we did a long time ago, back in the last unit, where we talked about different kinds of relations, linear and nonlinear. And remember what we did was this went up by 50 from 150 to 225. Let me do that. 225 minus 150. That is a change of 75, not 50. And didn't we say that when those are different, it's nonlinear? But when I went from 4 to 7, I went up 3. So that didn't happen in the last unit when we did questions like these, because these were always the same. So this looks like they are different, and they are different, but that's because these are different. And 50 for 2, 50 divided by 2, which is what we already did, gives you 25. But 75 divided by 3, well, also gives you 25. So it's the same change. And the reason why that happens where it didn't before is because these are different. Okay, and EQAO likes to do this. They like to give you tables where this changes. And so that can make it very tricky. So just be careful of that, and just that's something to think about. It'll come up for us again. We'll talk about it again, but this is something to watch out for. Okay. I hope that's clear. This mixed a little bit of everything because we talked about rules, but we talked about some information from tables and from graphs, and kind of went back and forth. And again, it's all about making these connections about what it looks like in a table, and also what the same thing looks like in a graph is really helpful. One thing that I want to go back to, and I think we can take a look at it here, is if you're looking for a different kind of strategy, if you're feeling like this isn't really working, here's a possibility. Okay, I could find a whole bunch of points and write them out in my own table. So time and cost. So this time was 1 and the cost was 100. The next time is 2 and the cost looks like 150. The next is 3 and the cost is 200. And so on and so forth. Looks like 4 and 250, and I'll stop there. Okay, and if I knew what the 0 was, I could add that in too, or I could use my strategy that I've done lots with tables to figure that out. that my start works out to be 50. And I could use that to find the change as well. So there's a totally different strategy. If you're not loving just using the information, reading it from a graph, try to just get the points from the graph, turn them into a table. If you're more comfortable with the table, that's a fine way of doing it. Might take you a tiny bit more time, but if you're comfortable with it, it's going to be faster for you for sure. Okay. So, and that would be for 0, right? So there's another strategy that you can think about. I hope that that's clear. We've done a lot of going back and forth between tables and graphs and rules now, and I really hope that it's starting to come together. Go back and take a look at some of the previous practice if you're not sure about anything, or rewatch some of these examples. But just, and always remember, what it comes down to is where does it start and what is the change? And that's the first thing you always have to think about and remember when you're doing any of these kinds of questions. And then you can take where does it start and what is the change, turn it into your rule. Um, and depending on the graph or the table and what it's counting by, it might be easier or harder to figure that out. But once you've figured that out, you've basically got the question solved, or if not solved, a good way towards solving it if you can figure out what the start and the change are. Okay, and that I think is it for that.